Hi, I'm Vihanga Thudugalage from 2024 A-level batch. Okay, so today we are going to discuss the 2023 A-level PO part B, question number 11. Okay, so in the A part they have given a few data for us. X is a real value and fx equals ax squared plus bx plus c, and they have given that a is positive and also a, b and c are real. And they're asking us to show that fx minimum is equal to minus delta over 4a, where delta is equal to b squared minus 4ac. Okay, so we can write fx equals ax squared plus bx plus c, and we can take a out and write x squared plus b over a x plus c over a. Then we can complete square this. As you all know, x plus b over 2a squared. So we divide this by 2 and write x plus that whole thing squared. Then we square this and minus it from this. So minus b squared over 4a squared, and we write this plus c over a. So we get a times x plus b over 2a squared, and we get the common denominator of this. So b squared plus 4ac over 4a squared. We multiply these two by a and 4. Yeah, then we can again open the bracket. A times x plus b over 2a squared minus, we can write b, we have to take minus out from this, b squared minus 4ac over 4a, because we multiply from a cancels out and we get 4a. Then this is the discriminant. They have given delta, so this is delta. So we can write this as fx equal to a times x plus b over 2a squared minus delta over 4a. So the minimum value of this is obtained when this is 0. So we can write when x is equal to minus b over 2a, fx gets its minimum value. Therefore, fx minimum is equal to 0 minus delta over 4a. Therefore, fx minimum is equal to minus delta over 4a. Okay, now we'll go to the next part. They're saying P and Q are real values and R, they are here real positive integers, and R is real. So let's write like this. Yeah. And they have given gx is equal to px squared plus 2 times square root of pq into x plus qr. And they are telling if gx equals 0 has no real roots, they're asking to show that r is greater than 1. Okay, so we know if there's no real roots, the discriminant should be less than 0 when a is greater than 0. Here a is p, so they say p is greater than 0. So discriminant equals b squared, this value is squared, so 4 times pq minus 4, a is p, c is qr. So I'm sorry, this should be less than no. So therefore 4pq minus 4pqr should be less than 0. So we can take 4pq out, 1 minus r greater than 0. If we divide both sides by 4pq, we get 1 minus r is less than 0, and therefore 1 is less than r, and we prove that. And now they say if the minimum value of gx is q, show that r equals 2. If gx minimum equals q, show that r equals 2. Okay, now here we can use what we found before. Previously we showed that fx minimum is minus delta over 4a, so we can use that here. So gx minimum equals q equals minus delta is 4pq minus 4pqr over 4p. So we can write 4pq equals minus 4pq minus 4pqr. So we can take 4pq out, then 4pq equals minus 4pq times 1 minus r. So we can cancel these two and we get 1 equals minus 1 into 1 minus r. Therefore 1 equals minus 1 plus r. We take this minus 1 to this side, so r equals 2. Then they are saying this is the curve and there's a tangent to this curve, and this point is 0, 1. And this equation gx when r equals 2. Therefore, they are asking to find p and q. Okay. Here y equals x plus 1 and gx we can take it as y equals px squared plus 2 square root pqx plus 2q, because that is saying when r equals 2, this is the curve. Okay, so at this point, if we put these two values for x and y, we get 1 equals x is 0, therefore 0, plus this x is 0, therefore 0, plus 2q. So we can tell q is equal to half. Then now, so we need to find p. So what we can do is, if we differentiate this, because here we know it's 1x, therefore the gradient is 1. So if we differentiate this, we get the gradient. Therefore, dy over dx equals 2px plus 2 square root pq. Then this is 1, so 1 equals 2px plus 2 times square root. We can substitute the q value. So it's p over 2. So here again we put when x equals 0, 1 equals 0 plus 2 square root p over 2. Then it becomes root 2 over 2 equals root p. And therefore, when we square both sides, 2 over 4 equals p, then p becomes half. Alright, so we found pq values. So now we can move on to 11 part B. Alright, so they say let a be real and px be a polynomial of degree 4. Show that x minus a is a factor of both px and p dash x. Then x minus a squared is a factor of px, where p dash x is the derivative of px with respect to x. Okay, so then we can take we can take px is equal to qx. Let's just take quotient and into x minus a plus 0, because the remainder is 0, because x minus a is a vector. So therefore pa is equal to 0. Let's take this as 1. Then if we take p dash x, there let's say the quotient is gx times x minus a plus 0. Then p dash a is also 0, as they have given in the question. Okay, so now because it's in degree 4, we can write this as px equals quotient times, we can take another symbol even, it's fine, we just interpret it here, so we can take qx, rather I'll take simple qx into x minus a squared plus we don't know whether like we have proved that the remainder is 0, so we'll take the remainder because here it's a quadratic function. We have to take a linear function, therefore let's take it as ax plus b. And let's take p dash x, so we have to differentiate this. So chain rule, we have to take qx times this differentiation of this, so 2 times x minus a, and plus this times the differentiation of this, so x minus a squared into q dash x. Then differentiation of these two, b goes to 0, then ax differentiated, we get a. So this let's take as Roman number 1, this Roman number 2. So from I1 and Roman number 1, we can get, if here we take as a, p a is equal to qx into a minus a squared plus a plus b. Therefore 0 equals 0 plus a plus b. Okay, so 0 equals a plus b. And if we take from 2 and Roman number 2, p dash a equals, this is 0, this is 0, so 0 plus 0 plus a, and this is 0 from the second equation, therefore 0 equals a equals 0, therefore 0 equals 0 plus b, therefore b equals 0. The remainder is 0 when x, rather we can say remainder is 0, therefore x minus 2 squared, x minus a squared is a factor of px. Okay, then they're saying let fx be equal to x to the power 4 minus x to the power 3 minus 6x squared plus 4x plus 8, where x is real. They are asking to deduce that x minus 2 squared is a factor of fx. They are asking to deduce. So we can use what we found previously here. So what we are going to do is, we are going to take when x equals 2, f2 equals 2 to the power 4 minus 2 cubed minus 6 times 2 squared plus 4 times 2 plus 8. 16 minus 8 minus 6 times 4, therefore 24, plus 8 plus 8. So minus 8 plus 8 cancels off. 16 plus 8, 24, minus 24 equals 0. Therefore x minus 2 is a factor of fx. Then when x equals to, we'll take f dash x. F dash x is, we have to differentiate this. So we get 4x cubed minus 3x squared minus 12x plus 4. So if we substitute 2 here, f dash 2 equals 4 times 2 cubed minus 3 times 2 squared minus 12 times 2 plus 4. Then equals to 4 times 8. 4 times 8 is 32. 3 minus 3 times 4, so minus 12. Minus 12 times 2 is minus 24 and plus 4. So 32 minus 12 we get 20. 20 minus 24 we get minus 4 and plus 4 is 0. Therefore x minus 2 is a factor of f dash x. Therefore, as proved before, using x minus a squared and px comma p dash x, similarly x minus 2 squared should be a factor of fx. Then that's asking us to find the value of f minus 1. So f minus 1 equals minus 1 to the power 4 minus times minus 1 to the power 3 minus 6 times minus 1 squared plus 4 times minus 1 plus 8. Then we get minus 1 to the power 4 is 1. Here minus times minus 1 is plus 1. Here minus 6 times plus 1 is minus 6. Here minus 4 plus 8. So here plus 2 plus 8 is 10. Minus 6 minus 4 is minus 10. So minus 10 plus 10 equals 0. Therefore, x plus 1 is a factor of fx. And they're saying to factorize fx completely. So we have two factors here, x minus 2 squared and x plus 1. So therefore, we can write fx is equals to x minus 2 squared times x plus 1 times, because here x squared and x becomes x cubed, but fx we have a degree 4, so we can say px plus q. Okay, so now we can write fx here. So x to the power 4 minus x cubed minus 6x squared plus 4x plus 8 equals x minus 2 squared times x plus 1 times px plus q. So by equating coefficients, if we equate x to the power 4 coefficients, it's 1 here, so 1 equals here x squared into x into px, so we get p. So we found p. Then we can straight away equate constants. Then we get 8 here equals minus 2 squared is 4. 4 times 1, 4 times q equals 4q. Therefore, q equals 8 over 4 equals 2. Therefore, we can write fx equals x minus 2 squared into x plus 1 into px plus q. We can write x plus 2. And we are done with the 11th question of 2023 A-Level PO Part 2.
Ride or die. I keep boys by my side. Know that they ride or die.